So we're looking at the sine rule, and like the cosine rule, we don't have to remember the formula, although it's quite a simple one. It will be given in the GCSE exam. So the sine rule, the formula is A over sine A, where the big letters are angles and the little letters are the lengths of sides. So A over sine A equals B over sine B equals C over sine C. Now the sine rule is best explained if we look at it with an example. So if I draw a triangle, and we'll label it first, just so we know what we're talking about with little a's, big A's. So we'll look at this triangle here. Again, like I said, the big letters are angles. So if I call this one big A, big B, and big C, just like the cosine rule, little a is opposite big A, little b is opposite big B, and little c is opposite big C. So knowing how to label the sides is obviously half a battle, so we'll look now at a problem and we'll work through it using the sine rule. So again, if I'm given a triangle, and we'll call this one little a here, this one 12 centimetres and this 72 degrees, and this angle is 55 degrees. It's also important that I mention that the sine rule can be used with any triangle. Now that's if it's right angled or non-right angled, so a very useful formula. Now we've got the formula A over sine A equals B over sine B equals C over sine C. So let's label our sides. Because we've got little a here, we know that this one will be big A, and we'll call this angle big B, which means this one will be little b. Now you'll notice if I don't have a C, well with the sine rule I don't need that. Depending on what I'm given, I can use either two parts or all of the formula. So substituting in, I'm going to get little a over sine 55 degrees equals 12 over sine 72 degrees. Now, as always, you'll notice that we want to find the value of the unknown, that being A, the length of A. So the first thing I'm going to do is multiply by sine 55 to get A on its own. Now that leaves me with A equals 12 over sine 72 times sine 55. Now, using my calculator, I'm going to work that out. So if I just type it in, 12 over sine 72, at this point make sure you press equals so that you don't multiply sine 72 by sine 55. So the answer to 12 over sine 72 is 12.61754, etc. Now I'm going to multiply that answer by sine 55, which gives me my answer of 10.34 centimetres, and that's the 2 decimal places. So let's look at another example. Looking at this example, you'll notice that this time we have the length of two sides, an angle, and we're looking to work out an angle. Now when this happens, the sine rule also proves very useful because we can just flip it on top of itself. Now by that I mean A over sine A equals B over sine B equals C over sine C. Can also be written as sine A over A equals sine B over B equals sine C over C. So we literally just flip the formula on itself, and let's put our values in. Well, first of all, let's label the triangle. So if this is big C, then 17.1 centimetres must be little c, and I'll call 29 degrees big A, which makes 19.2 centimetres little a. Substituting in gives me sine of 29 degrees over 19.2 equals sine of big C over 17.1. Again, we need to rearrange first, so I'm going to multiply both sides by 17.1, which gives me 17.1 brackets sine 29 degrees over 19.2 equals sine C. And let's just get rid of this bottom part. So now we've got 17.1 times, in brackets, 7 sine 29 degrees over 19.2. I'm going to do sine 29 over 19.2, which gives me 0.02525, etc. I'm going to multiply that by 17.1, which means that 0.43 to 2 decimal places equals sine C. Now, I don't want sine C, I just want C. So I'm going to do the inverse of sine, which is to do sine minus 1. Now, to get that on my calculator, I just press shift sine. So shift sine of 0.43 gives me 25.47 degrees, and that's the 2 decimal places, and that is C.